Maybe I can say it.
Okay.
You're all getting the message that we were started recording. Sorry.
Yeah.
Right, yeah, that's good. Yeah, so our next meeting, will probably be in early to mid-March, and we'll try to do in person if we can, but we're still working on the speaker for that. We have Robert Zublin on April 27th, hopefully in person at the hall. He's committed to that. And then Alan Stern wants to talk about his Virgin Galactic Spaceship 1 or Spaceship 2 flight sometime in June. So that's the future, but we'll let you know on March once we know the date for sure and who will be speaking.
No.
Okay. So I guess John or Dewey, do you want to say anything?
Not really. Roll tape, shoot.
Okay. So Leonard,
Well, let me bring him up.
Yeah,
let us know if you have any trouble hearing. No,
okay,
no, I tried that.
okay. Okay, well, let me start a little bit with the funeral talk. We got, when I was doing some research, I ran across today, January 27, 1967. This is the Virgil Grissom, Ed White, Roger Chaffee were burned to death in a flash fire as they were getting ready for their Apollo 1 mission. So that happened, you know, a long time ago. Let me move it up. Next slide. You know, we have a funeral on Mars as well. Next slide. Yeah, it basically, you know, the Ingenuity, the Mars helicopter, it's been doing so much on the red planet. And anyway, it took its 72nd flight. And it was only supposed to take 5 when it was put on the ground on Mars. So it's been 3 years of operating. But this last flight, they went up to a pop-up altitude and came back down. Apparently, one of the rotors on the helicopter hit the sand or something. They're not quite sure yet. So anyway, it's pretty much over for that, or it is over. They're claiming. So they're not going to do any more flights. So that's a funeral there. Next slide. It's been a very strange couple of weeks with the moon. We had an astrobotic private lunar mission that NASA put quite a bit of money into, but it's privately built and it took off, and it was in trouble within a few minutes after launch. Because of a propellant leak and a valve that didn't work right. And so anyway, it was pretty much doomed, but anyway, it swung all the way out around toward the moon and it came back, and then they re-entered it in the Earth's atmosphere. So it's kind of, it was pretty much a bust. But this is one of the commercial lunar payload services missions that NASA is bankrolling and helping get the private sector to do technology capabilities that they can showcase later on at the moon. So next slide.
Yeah.
The next one is coming up. It's next month. So it's on a totally different private vendor that's doing it. This is Intuitive Machines. It takes off, I think, something like mid-February. I'm not quite sure the date. I don't know if they set it yet, but it's coming. So this will be launched on a Falcon 9, and you know, it'll try to make a landing on the moon. And it's pretty got a lot of really interesting experiments and Again, NASA bankrolled, but it's got a lot of private mementos on it and all kinds of things. Plus a camera, as it's coming down, it'll shut off this camera, and it's supposed to record the plume that the lander will be making on the moon. So anyway, next slide. That's coming up. Big news was really Japan. They have a mission. I can never remember exactly what SLIM means, but they worked on it. Smart lander for investigating moon. Anyway, this thing landed the other day after it took pretty incredible trajectory on the coming into the moon. Ejected 2 probes and basically nose dove. I don't know what is it. Into the moon. So there's no parking ticket involved here, but it cut off some solar panel capability. So the thing's sitting there. This picture was taken by one of the ejectable spacecraft. So now the Japanese are kind of going into a mode of thinking that they can activate the core spacecraft SLIM. We'll see. One thing why it didn't work well, if you notice the nozzle on the very top of the spacecraft as it's pointing down, you see that nozzle? There should be 2. The thing blew out a nozzle on the way down, and it threw the whole thing out of balance. And great story about software trying to fix the problem on the way down, doing it on autopilot, but it almost did everything right. So next slide, but it's upside down. Okay, this is the little rover that it ejected on the way down, the Japanese SLIM. And it's made by a toy manufacturer, and it is taking pictures. And I don't think the battery lasts that long, but the thing's got a capability to row through this lunar regolith through kind of a strange motion that this transformer rover does. Anyway, it's another little side success story there. Next slide. Again, the Chinese are moving along on their space station. Next picture. One of the things that's going to happen here, you got to keep an eye on. They're going to launch their own lunar probe. This one will go to the far side, and it's all robotic. It will collect samples and then bring them back to Earth. Much like they did for the Chang'e 5. This is Chang'e 6 that's coming up. I think if everything is being reported mysteriously, I think the thing is going to take off likely in May. Yeah, NASA doesn't run the press office there in the Chinese space program. It's hard to see what's coming. The next thing. This is they're becoming more gutsy, China, with their plans to get 2 of their astronauts on the moon by 2030. And they're developing all kinds of test equipment and hardware. They're clearly moving along. And so there's quite a bit of wait and see about this program of theirs to put their own countrymen and woman maybe on the moon. 2030. Okay, next slide. Really kind of an interesting adventure in the desert. The OSIRIS-REx is a NASA spacecraft that went out to Bennu asteroid, Bennu, rendezvous with it, collected samples, come swinging back toward Earth. This takes years for all this to happen. 7 years, the whole mission. And it parachutes into the desert at the Dugway Proving Ground up there in a remote area. It's picked up in Utah. Next slide. And we were there and we loved it. It was great. This guy's the character that, all the asteroid material is captured in that ring that the guy's holding. And the guy is Dante Laurenti. He's a Loretta, Dante Loretta. And he is at the University of Arizona and a great principal investigator of this mission. So Barb took that picture on the left, and this one is somebody with a lot of worry because they couldn't get the last two fasteners off the collection basket there to really look and find out what the whole mission grabbed. So next slide. This took many months, and they had to develop special tools to do the last two screws to get the thing open. But anyway, a week ago or so, they opened it up, and they definitely got a lot of material on there. But a lot of material got collected on the top of the thing when they first looked at it. So they already at the university, there's quite a bit of activity of characterizing what those samples are saying. And I talked to Dante Loretta the other day. They can't tell you what they found yet because he said 45 abstracts in the Lunar and Planetary Conference coming up, and a major paper. It's one of a major paper on what they think they found. So keep an eye on that. Next slide. Last thing is, we just had a human private spacecraft launch. This is Axiom. It's a private group that that they buy the space on top of Elon Musk's Falcon and then the Dragon capsule. So they launched 4 of their guys. Those first 4 in the black, those are the guys that just went up and they joined the already crowded International Space Station. But the private astronauts are going to be up there for, I think, 14 days or so and come back down. So anyway, the next thing, we just had another flight of suborbital capability by Virgin Galactic. This just happened a couple days ago. And this is one picture from inside the Spaceship Two with the passengers that paid for their tickets. And they apparently loved it and came back, and everybody's safe and sound. So that just happened. And Virgin is, this is their, what did I put down here? 6th commercial flight with the passengers in March. It's the first time all 4 seats of the spaceship were occupied by private astronauts. It was a Ukrainian, an Austrian, and 2 from the United States made up the crew there. So I think that's the last thing, and thank you for listening.
If you have questions or comment, you just need to unmute yourself and you got it. Questions.
I've got one thing I've kind of been wondering about when you talk about the Chinese wanting to send people to the moon. I'm kind of wondering what the effect on the American psyche will be for that. Because, will it be like it was in the 50s and 60s where we go, oh my gosh, we've got to catch up, we've got to do that? Or will most Americans simply go, so what, we did that 50 years ago?
Oh, but yeah, I don't know how it's going to go, but either way, it's a story. So, Yeah, I think Nelson, the NASA administrator, is playing the China card when he's trying to get budget for NASA, when he's up on the Hill. I mean, he does go and, make sure that the lawmakers know that China's coming. And meanwhile, they just delayed the Artemis program, and that's we've gone to the right there, which is sort of to be expected. But then you have the budgets and the whole Congress, all the other people holding their hand up for money, and all those agencies. I don't know how it's all going to run out. But anyway, so who knows? And maybe nobody will care about China going to the moon. I think it's a space race. I think it's diplomatically, they're going to use that as a chip. And so I think that's part of where you're going on the foreign policy, because the diplomatic oomph that would give China of being the first country to do it in the 21st century could be a nice slogan for a T-shirt.
Well, the Pew did a study back in, I don't know, May, early, springtime, where they interviewed a bunch of Americans who really think that United States, it's really important for the United States to maintain leadership in the space area. So, I mean, at least Pew showed that Americans are worried about this and watching the ball.
Well, I think, we could have I've written, Sputnik effect. We're going to go through another Sputnik moment, and sometimes that galvanizes the country to sort out what the priorities would be for the space program. So, right now it's kind of, to me, willy-nilly. I'm not sure what the whole program's about. The Artemis program is definitely the most expensive thing we've ever undertaken, the way it's going. And so then you have the drama of Elon Musk on the side of the Starship, and everybody, every time he gets the engines lit, he said, let's cut NASA out of this, So I don't know where it's going to go, but it's a story.
Hey, this is Larry. Question.
Yeah.
Over in Grand Junction. I'm waiting with bated breath for the next Starship launch, IT-3 out of
Texas.
Out of Texas. What are your thoughts on that? When do you think it's going to go? And what, if you were to put money on it, do you think they'll successfully orbit and mate for that demonstration fuel mating test?
Man, that's a lot. I don't know. I thought I saw something that Elon is talking about February, but I think for the next, he's stacking stuff. People are working on it. I see you can go into a view cam and you can see what he's doing. There's a lot going on. So he's getting ready, and what who knows if it's going to work? I have no idea, man.
I'm placing bets it will. I've got some money on this one. It's going to work.
Well, no, I can't get into all that. It's I worry that too many people count on this, to be the Christ coming, moment or something. There's a lot of work there. It's got to be wrung out. Like you said, refueling in space is maybe not going to be a big deal. Maybe it's going to be a big deal. He's got to showcase all that. And meanwhile, the Artemis program will, at some point, cut bait with him if he's not ready. We're going to have to use Jeff Bezos and his Blue Origin folks. So anyway, that's it for me. I think I'm talking to
Oh man, I guess it's my turn then.
Yeah.
So while I get this queued up, I just want to say I have a lot of information coming at you. There was a lot going on in 2023. There's a few things going on in 2024. So if I'm speaking too fast, say, whoa, John, slow down. It's okay. And then also, I don't think that'll happen, but you never know. And then the other thing is, if you got questions, fire them off. while we're talking, because like I said, there's a lot of information. It'd be just better to, answer questions if I can, while we're doing it. So, with that, this whole
John, will you say a few words, for the new people anyway, about your background and, what you're up to? That'd be great.
I'm up to, about 5'9". I'm getting shorter. No, I'm joking. Yeah, so thanks for reminding me, Barb. So, John Williams is the name. I'm a sky watcher, although I'm not living in Coal Creek Canyon anymore. Last year, well, my background is in science writing journalism, but I've switched to web development and design, and application development. I work for the National Solar Observatory, hence the pictures in my background. We went to the annular eclipse in Texas, and we will go back to Texas for the total solar eclipse on April 8th, and we'll talk a little bit about that in this talk. Anyway, half of my job is IT, doing the website, and then the other half is education and public outreach. So there was a time when I did all the science writing, graphic design, photography for the observatory, but now we've hired some people, so I just get to do the website and do technical stuff. So my job has changed, but that's okay. And I'm also a NASA JPL Solar System Ambassador. So I've been doing that for almost 20 years, sharing the excitement of space exploration with, well, I said it in the newsletter or the email. I'll do it to just about anybody who will listen. So Barb has volunteered to listen anytime, and I appreciate that. Anyway, so, well, the talk is going to be on, let's see if we can get to advance. Holy smoke. What happened in astronomy in 2023? That's going to be the first part of it. We should look forward to in 2024 from an astronomy and space science sort of lens. And then also I'm going to talk about some of the things that are happening in the night sky in 2024 that we might want to pay attention to, such as an eclipse, which dime a dozen of these things. But anyway, so while I was getting ready for this, this to me was so far the most interesting story in 2024. This paper came out just a week or so ago that, the Milky Way is what they call the barred spiral. It's not quite a spiral. It's got a bar in the middle and some arms. And what we thought that was the way this Milky Way formed from the get-go. That's just one of the theories. But it looks like from this image from James Webb that they're looking at these. Let me back up just a second. About 20 years ago, they looked at these galaxies that are formed about 650 million years after the Big Bang. So 12 billion years ago. In the early universe, we're looking back in time with the Hubble and James Webb. And these scientists couldn't tell, astronomers couldn't tell if these galaxies were just elongated or if they were seen edge on, like a Frisbee. You hold a Frisbee like this. And so James Webb is now designed specifically to see the kind of wavelengths that for these faraway galaxies. And what it shows is that these things are probably pickle shaped. They're probably elongated. They're not edge on. And so they're looking at these galaxies that were probably proto Milky Way type galaxies. And it's kind of blowing their mind a little bit with these new discoveries. And we'll talk a lot about that tonight. James Webb is really rewriting almost every day some of the textbooks that we have. So remember, this was the most interesting story so far of 2024. We expect a lot more. But we're going to start with the solar system. And this year, we discovered that Mercury is shrinking. Now, this kind of is a no-brainer. Mercury is the smallest planet, the most innermost planet. And we think that we see on the surface of Mercury these cracks. They call them scarps. The moon has them as well, and it happens when we see them on mud plains. The mud cracks. Well, the same thing's happening on Mercury, but it is happening. We thought that these cracks were 3 billion years old, that Mercury shrank and caused these cracks. But a new study that's come out from Johns Hopkins is saying that it appears that these cracks are only about 300 million years ago. So Mercury is probably still shrinking to this day, instead of having shrunk as much as it's going to 3 billion years ago. So we have a dynamic solar system going on. I don't know if you remember from, this is Venus, an image that NASA JPL took, and it's looking through the clouds. But when Bob Grimm talked to us, I don't know, a year or so ago, we were talking about they found oxygen in the atmosphere of Venus. And it was just a one-time discovery. And in science, we want to, we have a theory. We want to see, these experiments work again in the same way. So they have some new information from the NASA Sophia aircraft, which is a 747 that flies and does infrared, had an infrared telescope on it. They've since decommissioned this thing. But when it flew in 2022, they found oxygen again in the atmosphere. So now we have 2 sightings of oxygen in the atmosphere. Now, before you get real excited about this might being, that Venus might be habitable, which it most definitely probably is not, because it's so damn hot. Scientists think that the oxygen comes from the breakdown of carbon dioxide in the atmosphere from solar radiation. So the solar UV radiation is stripping the CO2 into carbon and oxygen, and we are seeing that oxygen. So that was this year that we found this. The moon is older than we thought. A new paper that came out in 2023 suggests that we brought back minerals and rocks from the Apollo missions back to Earth, and they were looking at the Apollo 17 samples last year, and there are these impact zircon crystals that are from the time when the theory is that there was when Earth was still forming, there was a large Mars-shaped planet that crashed into Earth, and the moon spun out of that. And so these zircon crystals come from about that time, and they are older than other crystals that they saw in the other Apollo samples. So remember, Apollo landed in several different places on the near side of the moon. And so these samples could be, we're not talking a lot of time, 40 million years, but still, this pushes back the formation of the moon. And so they're refining that whole scenario of events. And so that was pretty cool. One of the things you notice, we're moving out into the solar system. So Mars, for whatever reason, we have no idea, it's been spinning faster and faster by about 4 milliarc seconds per year. So that means the days are growing shorter, but we don't know why. So so far there are no theories. They've just been doing these measurements. So look for that in the next few years. I'm sure that there'll be many papers on why it's possible that Mars is spinning faster and faster. On Earth, the days are getting longer and longer. We're losing rotational energy. So this is kind of curious. In 2023, we found a dozen more moons around Jupiter. This is a cool image. This is the latest image from Juno of Jupiter. So very pretty stuff. So Jupiter has now 92 moons, but Saturn has even more. In 2023, we discovered 62 more moons around Jupiter for 145 moons. Crazy amount. This is Jupiter's polar vortex. So these atmospheres of Earth, Venus, Mars has a polar vortex on the ground in the ice, and Saturn, Jupiter have it, and now here's Saturn's polar vortex. Well, now it turns out that Uranus, which we thought had a pretty inert atmosphere, which wasn't, it looks pretty blue and it's very calm looking, but it turns out this is images from the Very Large Array. So it's a radar image of Uranus, and it shows that there's a polar vortex too. It looks a lot like Jupiter's, a kind of a hexagon shaped thing. If that, and I'm sure that Hubble's and James Webb are going to be checking this out any day, or if they haven't already, they've probably done that. So out to Neptune. Neptune keeps growing mystery spots. So back when Voyager 2 in 1987 looked at, flew past Neptune, it saw a storm that they think is a lot like the Great Storm on Jupiter, the Great Red Spot. But what they're finding as well with Hubble images and things, other even Earth-based observatories, they're seeing not only dark spots appear on Neptune, but also bright spots that come and go very rapidly. And then in 2023, all of the clouds, all the streaks in the clouds that we saw on Neptune, they disappeared. So we had this fairly boring looking, scene on Neptune, but they think that's due to the solar maximum, which is coming up. So right now the sun is going through a cycle that happens every 11 years where the sunspots, which is the best indicator of sun or solar activity, it's going to reach a maximum here in a couple years, and then it falls back down to near nothing. I don't know if you remember back in 2017, there was months and months when no sunspots were seen on the sun. And you'll see from some pictures that we have from some of our sky watchers, there are definitely sunspots on the sun. So they think that maybe Neptune clouds were erased by something going on with the solar cycle. This is an image from New Horizons, and it turns out what we thought was a crater is actually a massive icy cryovolcano, and that's just a technical term for an icy volcano. So it spits out magma that's water ice or icy stuff. And so it was kind of an interesting look. It's cool that we review what we've seen and go, you know what, that doesn't look like a crater to me. That looks like something different. And so this thing is on the order of size of the Yellowstone supervolcano. There's a magma plume under Yellowstone that's rising. Of course, this comes out of JPL, and they're like, well, if this volcano on Pluto had oozed out any magma, icy magma, it would cover up Los Angeles. So that's the size of what we're talking about.
Can you point out the crater you're talking about, the volcano?
So it was right. Can you see my cursor?
Yes. Right
in the middle is this thing. That's not a crater. Apparently that's a mound. That's from what I understand.
Okay.
If anybody knows better than me, that'd be fantastic. But I had the same question you did, Dewey. So I was like, where is it? And apparently they zeroed right in on it. Anyway, Planet 9, formerly the planet known as Planet 10, X, it still may be out there. But the idea here is that we see minor gravitational pulls and tugs of the planets and probes that we think there's a planet out there that's 10 times the size of Earth out beyond the Kuiper Belt. So way out there. We haven't discovered it yet, although we've tried. But a new study this past year, in fact, it was just in December, it could be because of a gravitational anomaly, a new theory of gravity known as the modified Newtonian dynamics, or MOND, And this suggests that planets and stuff, stars near the edge of the Milky Way, which we're kind of on the outside edge of middle, experience a greater gravitational tug from the galaxies, the Milky Way galaxies, supermassive black holes. And so what we're seeing might be indications of these supermassive black holes instead of a planet that lurks out there unknown. So I know, weird, mind blow, but pretty wild. So we've now entered intergalactic space, and just recently using a thing I'd never heard of before called nanograv, which is the North American Nanohertz Observatory for Gravitational Waves. They've been studying pulsars for years now. Pulsars are the remnants of supermassive stars that go supernova, and the star collapses into a pulsar. Pulsars are rapidly spinning neutron stars. We're talking they spin, hundreds of times, if not thousands of times per second. So then they're very regular. And so astronomers have been using them to detect gravitational waves. A couple of years ago, using some of the instruments we have on Earth, they've detected gravitational waves, probably from the collision of two either massive black holes or pulsars that cause, a ripple out into the universe. And they've now detected, using this nanograv, they can kind of tease out the different types of gravitational waves, and they've found this hum, very low frequency. I tried to find a sample of it, but they didn't have a sample of it. But apparently it's just low thrum. Anyway, it's probably much lower. My voice doesn't go down there. So to me, I thought this was like the coolest thing. We hear the planets make sound and stars and other things, but now the whole universe, it's like a guitar string almost. It's just going away, going at it. Leonard talked about OSIRIS-REx. This is a close-up of that new tool that they use to get those bolts off, and they looking into it. So this was something that happened in 2023 that is super important to look at the material that was left over from the beginning of the solar system that we're getting off these asteroids and comets. So we're hoping to crack some information by doing that. Now, everybody's always excited about exoplanets, I think, because the number now tops 5,000. And just this year, this satellite called TESS, which stands for, it measures the eclipses of the planet, of the planet that maybe crosses in front of the star. Anyway, TESS discovered 2,000 of these 5,000s, or these 5,000 so far. So James Webb is key in trying to piece together some of the exoplanet stuff. And one of the things this year, I'm just going to go through these real quick, is that James Webb identified heavy elements in a distant gas giant. They found carbon and oxygen, which is different than our solar system. Jupiter, Saturn don't have any carbon and oxygen. They've got methane, ammonia, chemicals, molecules based on hydrogen and nitrogen and things like that. So this was kind of a James Webb, like when I said before, it's rewriting the textbooks. This is one of those areas where, we thought, based on our solar system, that we have, very, in the inner solar system, we have rocky planets, and then we have these gas giants because the volatiles have been swept out of the inner solar system into these, and then outside of that, we have these cold ice giants. Excuse me. That's our solar system. But what we're finding is that things are changing, are not the same in other solar systems. one of the, like I just pointed out, tests, which I told you, it to do these occultations of the planets across the star, it's a very short drop, or it's a very shallow drop in the luminosity of the star. Hold on 2 seconds, I got a call. Pardon me. Anyway, so test found this one with a very long orbital period, something like 400 days, which is a lot different than a lot of the planets we're seeing test sees, which are on the order of 10, 20 days. So these planets that TESS has been finding has been they've been very close to the stars. So this planet is actually farther out, and the orbital period they find is much, much shorter. Thank you. Dawn is taking care of me. One of the things that we don't have here in our solar system are these they call them super Earths, but they're more like sub-Neptunes. They're tiny Neptunes. They're ice giants, but they're smaller than our Neptune. And in this one planetary system that Tess found, it's a planetary system with 6 really closely orbiting sub-Neptunes. And this is within the orbit of Mercury in our solar system. So it's very strange what we're finding these things. We found a massive planet this year that's orbiting a very tiny star. We're talking on the order of this planet the star is 100 times smaller than the sun, and this planet is 100 times larger than Earth. So it's 13 times more massive than Earth, which equals something like 100 times the ratio of sun and Earth. So it's just a crazy size difference. A few years ago, we found this planet, this star system with several planets that were in the sweet spot in the Goldilocks zone where Earth orbits, where liquid water might be liquid, where water might be liquid. And so it was called the TRAPPIST system. It turns out we were all hopeful that these were, Earth-like star or planets, but it turns out that they're probably more like Mercury, hot, baked, no atmosphere. And so that's a disappointment, but it's good to know these things. There's a mini Neptune. Again, these things that we don't have in our solar system at all, these mini Neptune. It's has water on it, according to some of the spectrum that we're getting from this star. Now, our Neptune has no water. That's only reserved for either the icy planets, like Pluto, or Mars and Earth. This one planet that we found has metallic clouds on it that act like a giant mirror, which means it reflects something like 80% of the starlight from its star out into space. Earth reflects maybe 30%. That's it. It's called albedo. And so this thing is super bright, and it's because of these metallic clouds. Maybe it's a solution for climate change or global warming or something. Anyway, of course, we see planets losing their atmosphere, a binary star system home with 2 worlds. So it's like a double Tatooine. And then one of the wildest things, even hot Mercury doesn't have an atmosphere of vaporized rock. So this atmosphere is so hot that the atmosphere is actually like vaporized dirt. So crazy stuff. These are the things that we've found. Now, something to watch for in 2024 is we've talked a little bit about SpaceX and how much they've dominated the scene lately. The number of launches in this, sorry, it's an empty slide, I didn't finish it, but we're talking something like there was 90 some launches this year. There's going to be more than 140 this year. Most of those are going to be Starlink from SpaceX, which means that the number of satellites in orbit is going to jump from like 1,000 to more than 3,000 this year. So the organization that I work for, the National Solar Observatory, is run by a group called Aura, which also, we have the Gemini telescope in Hawaii and down in South America. They're building the Rubens telescope, which will do overall sky survey every day. The Starlink satellites are hugely impacting the night sky of these observatories on Earth. So something to watch. I mean, it's just gone nuts, from a few launches every year to something crazy. Now, we promised some pretty pictures. So this one is from Hubble. Hubble's still out there making great science. This is the dwarf irregular galaxy UGC 1891. This is Terzan 12, which you can see in Sagittarius, a little star cluster down there. Still pretty pictures. NGC 1333. This is a combination of images taken between 2006 and 2023. So, the astrophotographers here, we know we stack images. They're really doing some stacking to increase their stuff. And then Hubble's still looking at the edge of the universe. This image is 12 billion light years away. Some of the galaxies here are 12 billion light years. So this galaxy over here, this red one that's kind of curved, there's a big group of galaxies in this area that's causing these Einstein arcs. So, but at the same time, we look at close things. This is a Hubble. That's not an irregular galaxy. That's Saturn. And that was taken by Hubble this year. And here's James Webb's image of Hubble. Different wavelengths and more infrared. But it can also produce pretty pictures like this. This is Herbig Haro 46 and 7. These are protostars. Stars that are just now forming, and when they ignite, they shoot jets probably off the poles, aligned with the magnetic fields, and create these, it's like the birth of these things. We're all familiar with the Orion Nebula. And again, remember, there's the color palette for Hubble and James Webb are a lot different because James Webb actually is looking at a larger swath of the spectrum. So that's why the colors are a little funky to our minds, but there's a lot of science to be done in this area. We see a lot of star formation, these areas where the gas is clumping, the stars look all sharp. The rays are caused by the way the mirrors are. So that's not natural, but that's just the way. And it's a characteristic thing. Hubble's got its own star pattern, and so does Webb. This is a Wolf-Rayet star this is only 15,000 light years away. And the wild thing about Wolf-Rayet stars, they are very high energetic stars. They are supermassive, and the Earth's been, our solar system has been around for about 8 billion years. The Earth has been around for about 4.5 of that, and the solar system. And these Wolf-Rayet stars, they burn themselves out within 100,000 years. So they're super explosive, high energy, but there are only about 200 in the galaxy, astronomers think. So Webb is kind of expanding that. This is the Ring Nebula from Webb. And this reddish thing here is a dwarf galaxy. The Milky Way has, billions and billions of stars. I'm going to do Carl Sagan. Billions and billions. This galaxy only has millions and millions. These dwarf galaxies, they don't have very many stars. But this massive Whirlpool galaxy, lots of even more stars in the Milky Way, billions of stars. Star forming area, IC 348. Another star forming area that we can actually see in the summertime around Antares, Rho Ophiuchus, And then, you know, just to blows my mind looking at these really deep images of space. This is the Pandora cluster. It's 3.5 billion light years away, but this view is about 350 million light years wide. So it's many, many, many times the width of the Milky Way galaxy. Just this view. This is all the pretty pictures that that Webb shows us. Moving on to what's to watch for in space in 2024 in astronomy. And these are all tied to what we know. And we have no idea what some of the new discoveries are going to be, how many planets or moons are going to be, or how many exoplanets they're going to find. But they're supposed to launch Europa Clipper this year. This is going to explore Europa around Jupiter. We need to watch for the launch of Sierra Space Dream Chaser, which Stephen talked about a couple months ago. We have the Artemis 2 launch, which hopefully happens this year. We have a new satellite sometime this year called Viper. It's going to search for water on the moon. There's the Lunar Trailblazer and Prime 1 missions. And also, those are going to the moon. But Japanese have a Martian moon exploration mission. And we also have ESA's Hera mission going out to the asteroids, I think. So some of the things we do know about, though, we can watch here from Earth, is the total solar eclipse. And if you're not headed to this part of the country, on April 8th, you need to get in your car and go. You'll see Denver is sitting here at about 55% of the moon will cover the sun. I'm sorry, the entire moon will cover an area, but the sun will only be covered 55%, which is a lot. And you might see some dimming, but even the difference between 99% eclipse and 100%, it's like night and day. It's like when the eclipse happens, total solar eclipse, it's like somebody turns off the lights. And so I know that getting a hotel room in this area is going to be tough, but we should try. It's going to cover 14 states. This is Mazatlan down here in Mexico. It's going to cross right here. Over here near San Antonio. Eagle Pass is like right in the middle of Uvalde, Texas, and then covers all these states, goes right up along the border, and then exits out Maine. One thing to know too is that I know Dave's got his hotel room already set up for Texas, which is good because the farther south you are in April, the more likely there won't be clouds. So
John, I'm going to be in Mazatlan.
Are you? You're lucky.
Yeah.
So they're going to send a Kate station to Mazatlan?
Well, that's where I'm going to be.
Well,
I suppose I'm site number 0.
The Kate project is the Continental America Telescope Experiment. And it was run by the NSO in 2017, but now it's run by Southwest Research Institute with help from us at the NSO. And they're going to have 40 telescopes spread across in America, in the United States, across the eclipse path, every, I don't know, maybe 100 miles. And what this will do is, instead of just, at best, we have 4 minutes of totality for this eclipse. So this will extend the eclipse out about an hour, maybe a half hour. And it really depends on weather. So some of these will be clouded out for sure, I'm certain. But we, in 2017, we put together a pretty interesting movie and data set that shows kind of the development of the inner corona as it comes off the sun, which is something we can't see from space. So this is kind of exciting. And then to top that, they're going to do some polarization experiments, or polarization aspect of it, to show how the magnetic field is, how the magnetic field in the corona develops as well. So that's Kate, and Dave has been an instrumental part of it. He's lucky he gets to go to Mazatlan, so that's cool. In April also, unfortunately, it's going to be a bright moon, but the Lyrid meteor shower, which is usually about 10 or 15 meters per hour, which isn't horrible. That's going to be that time period. May 15th to 27th, again, kind of a bright moon. They had a Aquariid meteor shower. The Perseid meteor shower is always the big one in August. That one's going to be a little bit, there'll be a crescent moon that night, or half moon of some sort. So it will be a little bright, but the Perseids are better after midnight. And this one always produces, well, every year is different. It can produce up to 1 a minute, 60 per hour. That's very optimistic. I've never seen anything like that. In the United States, there's going to be a partial lunar eclipse on September 17th, something to watch for. This will be, instead of the whole moon going reddish, it'll be just partial. Part of, the shadow of the Earth will fall, along the top or the bottom of it. In October, last year, there was a comet that was discovered by a Japanese observatory, and then Atlas. The Atlas is a telescope in Hawaii that they also spotted it. It's going to make its closest approach to Earth. I think it's funny. One of the Japanese scientists said, comets are like cats. They have tails and they just do what they want. And so it's a couple years ago, Neowise looked really good in the sky. Back in the 80s, we had Halley's Comet, and then there was a comet in the 90s that was really good. We're hoping that this one we'll be able to see in the sky, but it's just something to watch out for. As October draws near, we'll get a better idea if it's going to be something worthwhile to watch for or not. I think it would be very exciting to see a comet naked eye, but we'll see. And then in September, a long time, there's the Orion meteor shower, Orionid. And remember, these meteor showers have these big windows because they're usually either comet debris or stuff like that the Earth kind of crosses through the path of. Sometimes these are small areas, and sometimes this one's a large, wide, I call it a dirt road. I mean, it's got gravel and sand and whatever, and we just pass through it and we catch whatever. And then in December, another good meteor shower is the Geminids. So these are the highlights to watch for in 2024. There's the eclipse path again. How many people are going? Everybody got plans? Anybody? You'll have to unmute yourself if you want to chat, but
anyway, yes.
yes. All right. So moving on to us awesome Sky Watchers. Excuse me again. Mark Kutcherreiter sent this in. He took this on Solstice Day, and look at all those sunspots. I love the picture. Judy also. Judy, tell me about the filter you got. Do you have a neutral density filter?
It's a 1 million neutral density, which means you hold it up to the lights in the living room and there's no light to get through it at all. But I was out playing with it and trying to figure out what camera settings to use with the neutral density. The first time I tried, they looked like moonshots. They were just a white blob with interesting clouds around them. But today I got this one, and it came out very, very blue. So it took half the evening to try to get the blue out and make it sort of a neutral color. But I've got 2 months to play with it.
I need to start doing that too. I got to go out the other night. This is Chimney Rock. Down here in New Mexico. It's at a place called Ghost Ranch, which if you're familiar with New Santa Fe area, this is where Ghost Ranch is near where the ranch that who's the artist?
Georgia O'Keeffe.
Jeez, thanks. Sorry, I'm an idiot. So anyways, she painted this thing, but it was supposed to be clear this night, and right about where this cloud is, that was going to be where the Milky Way was.
Uh,
Ah, well, c'est la vie. We got nice halo. But what's wild is that that's the same scene, just 2 feet higher. So there's this is the Chama River. And the glow in the distance is Albuquerque. So you can see Sirius is the bright star, and Canis Major. But what was wild is that this is the halo. I was trying to get, I was trying to mess with, you can see Betelgeuse sitting there with kind of a reddish tone, which is pretty cool. That's what I was going for. But if we zoom in, there's a lot going on. So there's Orion, and here's the Pleiades and the halo. Jupiter was sitting there. This is a half moon. And then I'm looking up and I'm like, what in the world? At the very, very top of this, you can see some contrails, and you can see it over on the edge. I'm sorry. There's a bunch of jets. There's 7 of them, blue or green and white or green and red lights. I didn't notice at all. Sorry I didn't center that better, because it was kind of cool. It's one of those things I'm sure all the astrophotographers say, oh, I had no idea that I caught that, And one of the things I've been doing is going back through old images that I've taken of the Milky Way and trying to use the techniques that I've learned in the past couple of years, gotten better, I hope, and drawing out better pictures, images. So this was taken several years ago, but it's been my winter project other than moving. I'm going to leave you with this. One of the other things that we kind of discovered in 2023 was that this seems like a no-brainer, that the sun is older than the earth. But what's wild is that Earth's water apparently is older than the sun. And this all comes from, we can now, based on some science that we've done with the ALMA, the Atacama Large Millimeter Array, it's a big radio telescope down in South America, is that we can trace the water vapor to using other stuff. So like we've seen water vapor around a star called V883 Orionis. It's a really young star that's about 1,300 light years away from Earth. And it has the same chemical markers as water on Earth, which might not be super important, but it kind of supports an idea that's been around for about 20 years that water is even older than the Earth. But unfortunately, we weren't able to kind of tie things together until this the ALMA study. And so they've been able to now show that there's a path from star forming clouds and planets to, or from the star clouds that, where the stars form, and now the planets. So water came first, not the other way around. The sun didn't come first, if that makes any sense. I thought it was cool. I thought I would leave you with that. And now, sorry, it's David's turn to share his screen. Thank you, Dewey.
Yeah, thank you, John. That was great. Really appreciate that.
I'm sorry it was a lot.
No, that's great.
Divine structure.
David's going to really put perspective on things.
Says your screen sharing is paused. Is that you?
Let me see. I say you've started it.
Your screen share is loading.
Oh, there it goes.
You are screen sharing.
So, David, can you tell us who you are or a little bit about yourself, please?
Okay, am I sharing?
Yes, you are.
Okay, great. I'm an astronomer emeritus for the National Solar Observatory, which has little to do with what I'm going to talk about tonight and what I talked about last fall, which was a passion for night sky astro imaging. My career was in developing instrumentation for solar physics research, and I ended my career as instrumentation scientist for the Daniel K. Inouye Solar Telescope, which is a 4-meter diameter solar telescope that has just gone operational in this last year. Pretty exciting to build a 4-meter diameter telescope and point it at the sun. You can burn a lot of ants with that, and you can do a lot of research with it too. In anticipation of tonight, there was a call for sharing astro photos, and I sent one out that I have taken recently with a telescope that's not much bigger than a half of your 7x50 binoculars. It's a 55 millimeter aperture telescope with an astro camera on the back of it. And I took this image in Cassiopeia. It's about as big as your closed hand at arm's length, the field of view. It's 10 degrees across. That's sort of 20 moon diameters. So this is a huge piece of sky. But if you heard my talk this fall about the life cycle of stars, everything about them is in this image. There are dark molecular clouds, some of which have condensed to form star-forming regions, like the Heart Nebula here. There are new stars being formed in the center of the Heart Nebula, many of which are buried within these residual molecular clouds that are being blasted away by stellar winds from these young stars. But you can see a number of these young stars that have formed here in the center of the Heart galaxy. And it's kind of creating a hole in the middle and the surrounding gas that's emitting because of high energy photons from these stars that are exciting the gas that emits in the light of hydrogen. It's called a Strömgren sphere. Next door is the Sol Nebula, which I think looks a lot like the Running Baby Bison Nebula. But the same thing's going on. There are interesting pillars that are being carved out by the stellar winds, cluster of stars in the middle, a few dark clouds left over. After a while, these stars are going to blow away all of that nebulosity and leave star clusters behind. This is the double cluster next constellation over of Perseus. But maybe 100 million years ago, this would have looked something like the Heart and Soul. There's kind of a cycle of life of stars going on here as well. Here in the upper right of the image are 2 planetary nebulae. So here are stars that are solar size, maybe up to 5 to 8 times as big as the sun, that have burned through all of their helium, all of their hydrogen, have been processing oxygen, maybe a few heavier elements. And each time it goes through one of these cycles, the nuclear reactions start in the core and move out in the shell, getting larger and larger and larger and expanding the whole star. When it's pretty much exhausted that atomic species, it will collapse back down. Its compression heating will ignite the next heavier atomic species, and it can go through the same cycle again. But when it's not big enough to actually ignite much beyond oxygen, it'll leave an oxygen shell, which is this pretty blue-green. This particular one, called the Bear Claw, is twice as big as the Ring Nebula that we saw in that Webb image before. Gives you an idea of what the size of this is. Stars that are more massive than that end their life with a supernova explosion. They burn through all the atomic species they can up to iron, then collapse to either a neutron star or a black hole, and that explosion blows off the outermost layer. And so it's faint, but here is a supernova remnant. It's called G132.6 plus 0.15. It's actually one of the larger supernova remnants that we can see, and one of the older ones. It's like 50,000 light years, 50,000 years old. The papers say that it was a Wolf-Rayet star, which is short life, has an intense stellar wind, could have had a shell around it created by its stellar wind, but when it exhausted its ability to do nuclear reactions in the core, it collapsed, blew up, and then that explosion interacted with that shell and created a shock wave at about this diameter, which made it a little more intense, maybe lasting a little bit longer. There's one paper says there is a pulsar in the center of this. So there's even more in this image. So beyond the Milky Way, so this is in the plane of the Milky Way, zillions of stars. But behind the Milky Way, if we look completely through it, here are two galaxies. These are called Maphei 1 and Maphei 2. The Milky Way is about 100,000 light years across. These are 10 million light years away, seen through the Milky Way. The residual gas and dust in our galaxy has absorbed all but 0.5% of the light coming from these galaxies. So if we could see them outside of the plane of the galaxy, these would be some of the brightest galaxies that we could see in the sky. But here they're hardly visible at all, and haven't even been known for less than 100 years. So this is what you can do with a telescope that's not much bigger than half of your binoculars, with an astro camera and a good guider and some narrowband filters and a dark sky from my little observatory in southern New Mexico.
David, Lena has a question for you. So how is the age of the stars in various galaxies identified?
That's a tough question, and I can't say for sure. We do know a lot about main sequence, stars forming of different masses, existing on the main sequence for periods of time, and that the less than ideas of, say, a planetary nebula burning through its particular atomic species, going through expansions, compressions, expansions and compressions. By velocities of these shells, we can infer how long it's been doing that. So we can go back in time to say, okay, when was it back to being star-sized? I'm sure there's a lot of other good techniques for estimating ages as well. We need an astrophysicist.
From what I understand, too, we can, because as we go out into the universe, the farther that we are, the farther away a galaxy or a group of stars is the faster they're receding from us, the redshift, so we can get an idea, really rough idea about how far the galaxy is away. And then from there, what David's talking about, main sequence stars, red stars tend to be the older, bigger stars, but not always the case. Yellow, white stars tend to be, like the sun. We're just using us as an analogy. Blue stars tend to be hot, younger stars. So those are the kind of the framework that we work in to figure those things out.
Girl, Daisy, I know.
Dawn's talking to our pup.
I see that it's 8:16. Shall I talk about another image?
Go for it.
Okay.
Yes.
Yes,
My talk went much faster than I thought.
I have a quick
Um,
question on the existing image. Is this RGB and maybe a little extra H alpha or something like that?
Nothing at all like that.
Okay,
So
that's why I asked.
This is that same little telescope. I have filters on the back of the telescope that allow the ability to look at specific atomic species. And with these filters, I can look at hydrogen alpha, which is nice deep red color, sulfur 2, which is even redder, oxygen 3, which is kind of a nice teal color, and hydrogen beta, which is also kind of a teal color, maybe a little bit bluer. But I create monochrome black and white images of each of those 4 emission lines. And then I can play with those 4 images to decide what colors I want to assign to those particular atomic species and in what ratios. And in this particular image, I removed all the stars and then assigned colors in a way that would try to differentiate as best I could between what was actually hydrogen, what was oxygen, what was hydrogen beta, and what was sulfur 2. And by assigning quite diverse colors, you can do that. So hydrogen is red. Oxygen is kind of greenish blue. Hydrogen beta is blue with a little bit of green. And then I decided to make sulfur white because sulfur appears often by shocked regions in these molecular clouds, and those occur on the edges. So as you can see along the edges, there's a lot of white, which is the emission from sulfur. Here's a lot of green in here, so there's a lot of oxygen 3. So it's a way of trying to identify what atomic species are emitting in this interesting part of our galaxy in the Milky Way. All the dark clouds are between us and the colored background. So they're kind of lurking over the top of it. And then behind it is the emission from these nebulae where stars are being formed. The blue one is the North America. So here's the Gulf of Mexico, here's the Sierra Nevada, and maybe down Baja, Mexico. Florida's over here. Over in here is the
We're
Pelican
not seeing your
Nebula.
cursor.
Okay. Well,
We're
You
still
didn't
seeing the
change-
heart and soul.
you are.
Yeah.
Yeah.
Well,
We have a
that's
question.
bad.
We have a question for you though, while you try to figure that out. What do you mean by shocked region?
That would mean that, say, a supernova went off and blew up. It says resume share. And the shock wave from that has hit clouds in nearby molecular clouds. And compressed the region, heated it up, excited it to the point where sulfur atoms can be emitting. Let me stop the share and let me restart the share. And let me pick the image I've been talking about, which from reactions I thought we had been seeing.
Sorry.
Oh, okay.
Okay.
Well,
So now you can
I was
see-
asking about the previous image and the filtration on that.
Yeah, so that one, hydrogen was red, oxygen was teal.
Yeah.
Now it
Mixed
makes
in a little
sense.
bit of, mixed in a little sulfur is orange, but it wasn't significant.
Well, that
Here,
makes more sense. Thank you.
we're differentiating a lot more. Obviously, red hydrogen, lots of oxygen here, lots of oxygen over in here. And then I'll zoom in again so we can see that region of the Sierra Nevada where the edges are emitting in the white, which is the sulfur. Okay, how about the Pelican Nebula? Here's the eye, here's the beak of the pelican, here's the top of its head. Star forming region, lots going on in there. And young stars are carving out the molecular cloud. John mentioned a Herbig-Haro star, which is an extremely young protostar that's rotating and emitting gas at the poles of that star. So can you see at the tip of this particular column where that stellar wind is eating away everything but a column underneath it, but there are jets sticking out on both sides of it. So it doesn't take a James Webb sized telescope to see those features in the galaxy.
Is this the same size telescope you used for the other image?
It's the same telescope.
Same telescope.
Yep, it's just a different way of mixing the emission lines together. Okay, that's what I had to show off.
Quite
Very
impressive.
cool.
Yeah, that's amazing. Thank you.
Well, that concludes tonight's talks. If you have any questions, just unmute yourself and fire away, or if you want to mention something, tell us where you're going for the eclipse, whatever.
Yeah.
Yeah, this is Mark.
Vail,
Oh, hi. Yeah, this is Mark. I'm going somewhere in Texas. There's the Colorado Springs astronomy group is renting out some acreage on a ranch.
Do you're muted. You were going to say something, Judy?
I just said we're going to Salesville, Arkansas. It's probably a little cloudier, but we'll try.
Well, you never know.
Yeah.
Just historically, it's a little cloudier the farther north you go.
John,
Yes, sir.
John, look at my post. See if you've seen it before.
So, George, is
They're going to do another number of telescopes watching the eclipse again, like they did the last time.
cool. George had put a message in the chat about the nationwide eclipse ballooning project. So will you talk about that next, after
I
April?
don't, I just got the email today
Oh, okay.
telling me about that. I thought, oh, wow, John mentioned about what was done last time. I said, well, just found out today they're planning another one, and that's the information I received.
There's a huge array. This one is a citizen science one. Kate is kind of a citizen science initiative. There's also, there is a couple jets that will be flying along the eclipse path, trying to elongate. Shadia, gosh, I can't remember her last name. She sends a balloon up
Shadia,
as Hubble.
Shadia Habal.
Hubble. She sends up a balloon as well. It was kind of interesting in Australia. It got a lot of press because it was so different. Mainly it was to get above, they said, the clouds. There were no clouds in Australia. So that was kind of cool. There's just so many eclipse experiments going on.
When's the next eclipse anywhere?
There is, next year is in Iceland. Or is it in 2025 or 2026, David? The one in Iceland that goes over to Spain through Europe.
Iceland is 2026.
Yeah. And then in 2026, 7, 8, there's a cluster of them in Australia for the next 10 years. This happens sometimes. So there's that. The next total solar eclipse in the United States is 2048.
44.
Oh, sorry. I was 4 years off. I was
I
going
think
by
it's my
memory. Thanks.
99th birthday and it's in Alaska. Galena's right in the middle of it, so I'm planning on going for my 99th birthday to the eclipse.
I want to be there for that with you.
I'll make room for you.
Excellent. Lena, if you do meet John Mather, we would let us know if he can chat with us. Just contact Barb or myself, and we like having different speakers. So if you all know anybody who's doing something interesting.
Yeah, John Mather actually spoke at Lena's church in Washington, D.C. And so she got to know him, helped him sell his books, I think. Lena, did you want to say a few words about John?
Yes, he's an excellent speaker, and he showed some of the Webb telescope shots that they've taken. I'm sure all of you know that he was the director of the Webb Space Telescope project around the world, and he's just a very interesting person. And he's spoken to our church twice, is going to speak again, I think in April. So I thought if you were all interested, I would ask him if he would be willing to show up at one of the Zoom meetings and either present something or at least just be here.
That'd be great.
Yeah, Leonard mentioned maybe we could, if it could be zoomed from his next talk at your church, maybe we could let everybody know about that.
I don't know about that because the technology capabilities at the church are limited. So.
And Dewey and I will.
Yeah, we'll fly out.
Well, yeah. Know how challenging sometimes that can be. You know? Yeah. But yeah, let's, see if you can give a talk to a group.
Yeah, he lives here in Maryland. He lives in Maryland, so,
We could do
and there are a couple of people in our church that are, have worked for NASA and know him well, and so keep asking him to come, and talk to us at the church. And he's just a very interesting human being.
You know, he's a Nobel Prize winner.
Yes,
Yeah,
yeah.
that's why he's interesting. He's really good.
Well, I will ask.
Yeah, definitely. Yeah, we'll work on that. There need to be a Zoom, of course, but, yeah, that would be great.
Yeah.
Yeah, these photos of the galaxies, I'm just marvel at how wonderful it is, and how much information you can get from these photos. I keep thinking I ought to take an astronomy class. This is just so fascinating. I mean, I'm just enthralled by the intelligence and capabilities, and you all are such fascinating human beings. I don't know why I didn't go into science or astronomy as a career.
It's never too late.
That's true. I just don't know where astronomy is taught here in the Washington, D.C. area, even though we have NASA.
Yeah, we could help you find that. Yeah. Probably University of Maryland, where you've done some teaching, and you can probably do things online.
Yeah.
Too.
It was a really kind of an interesting, you mentioned University of Maryland. I think, yeah, he was a co-author, but there's a new, paper, research paper, and I can't remember where it showed, but it's I don't know if it was Nature, but anyway. Anyway, this guy, they looked at data collected in the Apollo program on seismometry and on the moon, and they think they found where the kind of epicenter of the earthquakes happen, and the moonquakes, and it turns out to be in the South Pole region in the same areas that the Artemis crew is supposed to get down to, and they kind of say, watch for landslides. So yeah, giant rocks coming down from the hills and landslides. So if you got enough worry to get down on the South Pole, but never mind looking for landslides. That's a new paper just out a couple of days ago. It was, what's shaking?
One of the
So
wild
Leonard,
things. Go ahead. Mark.
yeah, how much was the Artemis delayed?
I think they originally pushed it off the flyby to next year, and I can't remember what the date is for the human landing. It's it's unrealistic right now, frankly. It's just got they turned out with the delay supposedly was partly some problems that they found out on the first uncrewed Orion flyby of the moon and coming back at 25,000, and the heat shield did some weird things that they're puzzling over, and they're trying to figure it out. So there was a whole bunch of open technical issues that pushed it to next year for even just the flyby, like an Apollo 8 mission back way back. So next year, 2025. Yeah. So we'll see where we are.
Is the technology for the heat shield that much different than the Apollo stuff?
It is in a sense. I mean, actually, the ABCO is the group I think is still doing it, but Lockheed Martin is wrapped up in their deep, and they came up with new processes to make this, honeycomb structure, and how they applied it. So there is some squirreliness to the new technique that they don't understand, and nothing was really that bad, but they don't understand why it did what it did. And before we put humans on something like that, I think that's where the NASA, they put on brakes, if they can't get that squared away through wind tunnel testing.
I was listening to a kind of a conference speakers talking about NASA's engineering and they're striving for sort of a baseline excellence and trying to corral all the contractors into thinking the same way NASA does about safety.
Yeah.
Was like their number one goal. You gotta think about human safety the way we do,
Yeah. Well, we're dancing on fine lines there. We'll see how the commercial side really does. And I don't think this astrobotic lunar mission was a very good sign because NASA's wrapped up into that deep, and we paid quite a bit of money to have instruments that they were going to take to the moon and get going on the Artemis program checkbox. So anyway, we'll see how the next one goes. That's next month. So that's going to be an easy one to monitor because it'll be NASA will have it on TV and everybody will be looking at it. It's an expensive way to make new holes in the moon. That's all I'm worried about.
Well, it's funny to me. Astrobotic has been very nonchalant about the failure. They're like showing pictures. Oh, look, they're pretty Earth and stuff like that. And in the middle of it, you can see the damage that plume did to the structure. Like what you said, we paid a lot of money for this, and I don't know how NASA hasn't really said anything about it, but at the same, Astrobotic's going, it wasn't that big a deal, and it really was a big deal that thing
it's
failed.
a big deal. Failure, somehow we've got into failure as an option, and that doesn't seem to be the NASA culture, but again, there's going to be a lot of give and take on these private sector things. But, that story hasn't been written yet because I haven't written it. But, there is a way to find out what really went wrong there. And I would hope NASA does a mishap board or some kind of board. I think they are to look at what contractors screwed up. Because it may not have been Astrobotic. They bought a propulsion system from another company.
This was launched on the new Vulcan from the
I
Launch
forgot to
Alliance,
say
right?
that the big, success story was the launch of the Vulcan Centaur and that United Launch Alliance, and that's the first flight of that thing, and then putting that lunar probe on the top of it was gutsy. So the booster worked great.
And isn't that Dream Chasers?
Yeah, and Dream Chaser is going to be on that coming up whenever they get that packed up, put on the.
That'll be June.
When is it going to be?
June 12th.
June 12th.
Sorry, let me turn my audio down so I don't reverb so much.
Okay.
Great.
That sounded very alien-like, Steve, and I liked it.
Yeah.
Oh, thanks. But yeah, we're supposed to go out June 12th. And as far as private corporations are concerned, there's been a lot of interesting talk about how SpaceX has adopted a fail-forward approach, and that part of the reason why we move so quickly with private corporations is they're okay with losses, especially if they can justify the cost of the loss, write it off, do a lot of good science, and then build better faster.
Right.
So instead of making sure everything works great, they are willing to fail just to learn something. Is that what that means?
A good example of that would be SpaceX blowing up Starship multiple times just to get good test data and get incremental improvements.
Well, it certainly is spectacular.
Yeah. Yeah, that's what I said. It's really kind of an interesting time. And, at the end of the day, it'll wash itself out and we'll be ahead of the game. But it's just gonna be dicey now, and we'll see how some of the smaller private companies pull it together. So yeah. Good luck, June. Okay, I'm ready.
It was on the list to watch for. I had to include it just for Stephen. No, we should be watching this Dream Chase.
Thank you, sir.
Yeah. Anyone else have any comments or questions or?
I got a question for George. Who's doing all the balloons at the eclipse, on the eclipse event?
Oh, I didn't, what?
Yeah, who's doing all the balloons at the at during the eclipse?
Different I guess I'm getting feedback, so I better take off my earphones. It's different students from, I think, different universities. That's the way it was last time when our group here in Colorado partnered with the University of Colorado Boulder, and we sent up a balloon along with all the others that did it for the last one, a couple of years ago. And I just, this is something just new came through. So it's my understanding from what I said I got today is that they're doing it again.
So is
But
it
with
mainly
different institutions probably?
yeah, is it mainly a camera, wide angle camera kind of thing, or are they doing something in addition?
Judy, do you remember what sort of cameras they put on?
I don't.
Okay.
Judy, you're muted if you're trying to talk.
I unmuted and said I don't.
Okay.
Is it the same group that you mentioned in the text or the chat? I mean, then it,
I don't understand what you're saying. What is the same group? The University of Colorado here, was in a group that's doing it. We have not received in our balloon launch group any information or request to do it, something for them this time. But that group who sent this information to me that I received, that I put up here, I received it today. And so apparently the university group, this NEBP, it looks like National, hang on, let me move this slide up. Nationwide Eclipse Ballooning Project. And my belief is it's probably a group of universities and colleges doing something similar to what happened last time.
Yeah, okay. Thanks.
Can I go back to an old topic here? Lena, you asked about learning about star ages and so forth. I think you'd enjoy reading Dava Sobel's book called The Glass Universe. It describes how we know much of what we know about stars, how we were able to classify them, and goes into how we know how far away particular objects are. And it all goes back to the Harvard College computers, which were the women at Harvard College University who, some of whom took the data on telescopes, but they analyzed the glass plates. That's why it's called the glass universe, to infer what we know about stars.
And as long as we're talking about places where you can go learn something about astronomy, I can't help but mention my YouTube series on astronomical spectroscopy that was based on a talk I gave to the Sky Watchers back in 2017. I was just checking, and there's not a link to it on the Sky Watchers website. So, John, I may send you a list of that so you can add it to the website.
Well, can you drop a link in the chat here?
Yeah, it's 5 videos, so it's 5 links. So I can do that.
Well,
And
send me the links too, and I'll put them up. I'm sorry about that.
it's astronomical spectroscopy, how we know what we know. And it was based on a talk I gave to the Sky Watchers back in 2017. I just expanded it from an hour and a half to 2.5 hours instead. So anyway, Lena, if you want to learn some interesting things about how astronomers do know what they know, you can watch that video series.
Thank you. Thank you very much. I'll take a look at it.
My channel on YouTube is Do Science, but being named Dewey, of course, it's Do, D-E-W, Science, if you want to look for it. But
okay,
I will add it to the chat, and then I will also email it to John.
great. Thank you.
Thanks.
I want to know, David Elmore, about when you said these oxygen spheres or oxygen, what did you call them? Oxygen
Shells.
shells.
Mhm.
And so I'm an extraterrestrial civilization. Is that oxygen available in a sphere that you can pull up and pump it, or what? You know, is that a real sphere of gas that's all oxygen?
It's ionized oxygen. It's had a
Ionized.
couple of electrons stripped off in order
Yeah.
to emit that particular wavelength.
But
And of
it's-
course,
you know, is it contained in a giant bubble, or is it, what did you call it again? I'm sorry. Shell.
it's a shell that's expanding.
Okay.
It was blown off when the star that eventually became a white dwarf collapsed after burning through its oxygen, and that collapsing caused a shock wave that's pushed this shell off into interplanetary space.
Oh, okay.
And it's, of course, it's not like an atmosphere. It's really, really diffuse. You have to go away to find another atom, but with enough size and path length, you can see it.
Yeah.
Yeah. For those of you who are interested in doing some more traveling this next year, our photography group is going to Fort Davis, Texas, the first week in October, specifically for dark skies photography. And it's one of those things, you can take the train, you can drive, you can fly. I'm trying to figure out some way to get there, not by myself.
Pick me up in Santa Fe. We'll go.
There you go.
It's near Big Bend. It would be amazing down there.
Oh, yeah.
McDonald
Yeah.
Observatory.
Right, we've got
John,
one night we've got
by
a
the
guided
way,
tour there.
this is George. I just did a search on the web for NEBP eclipse, and there's a bunch of information there. I didn't try and look at any of it, but anybody who's interested might look up the National Engineering Ballooning Project, NEBP space eclipse, and there's a bunch of information there for more if people want to know more about it.
Yeah, thanks. I'll look at that.
I was starting to say, I think we have a field trip set up for one night at the observatory. For whatever, guided tour or whatever.
And John has Daisy there.
She wanted to say hi. She turns off when the sun goes down. I'm surprised she's still up and about.
She likes the new house?
She likes the yard. Yes, she does. She seems to be okay, but she's being a huge mooch.
So many other, yeah, that's probably. Oh.
Sorry, I
You
thought I
want-
would stop the recording.